Alright, and welcome back to Chapter 5 of Memory and Processors. This chapter we're going to be talking about the memory technologies. Now, recall that random access memory, RAM, temporarily holds data and instructions as the CPU processes them, and that the memory modules used on the motherboard are made of dynamic RAM, or what we call DRAM. Now, DRAM loses data rapidly, and the memory controller must refresh it several thousand times a second. Now, RAM is stored on what we call memory modules, which are installed in memory, or memory slots on the motherboard, as you can see by the examples behind me. Now, there are several variations of DRAM, and they've evolved over the years. Now, here are the four major categories of memory modules. Now, all new motherboards for desktops sold today use a type of memory module called a DIMM, or dual inline memory module. Now, laptops use a smaller version of DIMM called a SODIMM, or small outline DIMM, and pronounced SODIMM. Micro-DIMMs are used on sub-notebook computers and are smaller than SODIMMs. Now, you learn about SODIMMs later on, in like Chapter 19. Now, an older type of module is called a RIMM, which is designed by Rambus Incorporated. Now, really old computers use what we call SIMMs, which are single inline memory modules. Now, you're unlikely to ever see these modules in the working computers today. Now, the major differences among these modules are the width of the data path that each type of module accommodates, and the way the data moves from the system bus to the module. Now, DIMMs have several evolutions. There's four versions of DIMMs, one RIMM and two types of SIMMs, which are shown in the table here behind me. Now, notice that the notches on how the notches of the modules are. Now, the notches prevent the wrong type of module from being inserted into a memory slot in the motherboard. In this lesson, you're going to see tons of different technologies that are used by RAM, and so many can get a little overwhelming. So, pay attention and be patient. You need to know about them because each motherboard that you might support requires a specific kind of RAM. Now, as you can see behind me, this one here is designed to help you keep all these technologies straight. Now, you might find this to be a useful roadmap as you study each technology in the chapter. And who keeps up with all these technologies? Well, this organization called JDEC, or JEDEC. And you can find them at jdec.org. And it's the organization responsible for the standards that are used by solid-state devices, now including RAM technologies. Now, the goal of each new RAM technology that's been approved by JDEC is to increase the speed and performance without greatly increasing the cost. Now, even though an older RAM technology is no longer used in new motherboards, RAM manufacturers continue to produce the older RAM because older motherboards require these replacement modules. Now, as we saw earlier, the dotted lines for SIMMs and RIMMs indicate these technologies are now obsolete, and all new motherboards today use DIMMs. However, if you check some retail websites, you can see that RIMMs can still be purchased. So we'll now look at each of these types of DIMM and RIMM modules, and then we'll wrap up the lesson with a quick summary of the technologies. Now, DIMM technologies. Now, DIMMs use a 64-bit data path. Some earlier DIMMs used a 128-bit data path, but those are now obsolete as well. Now, a DIMM, or dual inline memory module, gets its name because it has independent pins on both sides of the module. Early DIMMs did not run in sync with the system clock because they were too slow to keep up. Their speeds are measured in what we call nanoseconds, or if you look on the board, it might say NS. Now, which is how long it takes for the module to read or write data. The first DIMM to run synchronized with the system clock was what we called SDRAM, or Synchronous Dram, which has two notches and uses 168 pins. Now, don't confuse SDRAM with SRAM. SRAM is static RAM, and that's what we talked about in the last lesson. Static RAM is used in your processor memory cache, and SDRAM is dynamic RAM used on DIMMs. Now, synchronized memory runs in step with the processor and system clock, and its speeds are measured just as a processor and bus speeds are measured in megahertz. Double data rate RAM, or SDRAM, DDR SDRAM, or SDRAM2, or simply DDR, is an improved version of SDRAM. Now, DDR runs twice as fast as regular SDRAM, has one notch, and uses 184 pins. Instead of processing data for each beat of the system clock, as regular SDRAM does, it processes data when the beat rises and again when it falls, doubling the data rate of memory. Now, if a motherboard runs at 200 megahertz, DDR memory runs at 400 megahertz. Two other improvements over DDR are DDR2 and DDR3. Now, DDR2 is faster and uses less power than DDR. DDR3 is faster and uses less power than DDR2. Now, both DDR2 and 3 use 240 pins. Although their notches are not in the same position, which means you won't be able to make the mistake of putting a DDR3 chip into a DDR2 slot. They are not compatible, and the different notch positions keep you from making that mistake. Now, factors that affect the capacity, features, and performance of DIMM include the number of channels that they use, how much RAM is on one DIMM, the speed, error checking abilities, and buffering. All of these factors are discussed next. Single, dual, triple, and quad channels. When you look at a motherboard, you might notice the DIMM slots are different colors. Now, this color coding is used to identify the channel each slot uses. Channels have to do with how many DIMM slots the memory controller can address at a time. Now, early DIMMs only use a single channel, which means the memory controller can access only one DIMM at a time. To improve overall memory performance, dual channels allow the memory controller to communicate with two DIMMs at the same time, effectively doubling the speed of memory access. A motherboard that supports triple channels can access 3 DIMMs at the same time. Sandy Bridge technology introduced quad channels with the processor and can access 4 DIMMs at the same time. DDR2, DDR, and DDR3 DIMMs can use dual channels. DDR3 DIMMs can also use triple channels and quad channels. For dual, triple, and quad channels to work, the motherboard and the DIMM must support that technology. Now, as the figure shows behind me, it shows dual channeling and how it works on a board with 4 DIMM slots. The board has 2 memory modules, channel A and channel B. With dual channeling, the 2 DIMMs installed in the 2 slots labeled channel A can be addressed at the same time. Now, if 2 more DIMMs are installed in the channel B slots, they can be accessed at the same time. So in setting up dual channeling, know that the pair of DIMMs in a channel must be equally matched in size, speed, and features. And it is recommended also that they come from the same manufacturer. Now, a motherboard using dual channels was shown in the figure that we had earlier. And the 2 black DIMM slots make up the first channel, and the 2 blue slots made up the second channel. Now, to use dual channeling, matching DIMMs must be installed in the black slots and another matching pair in the blue slots. Now, know that the second pair of DIMMs does not have to match the first pair of DIMMs because the first channel runs independently of the second channel. Now, the 2 DIMM slots of a channel are not populated with matching pairs of DIMMs, and the motherboard will automatically revert to a single channel. Now, for triple channel installation, 3 DIMM slots must be populated with 3 matching DDR3 DIMMs. Now, the 3 DIMMs are installed in the 3 blue slots in the motherboard. Now, this motherboard has a 4th black DIMM slot. Now, you can barely see the black slot behind the 3 filled in the slot photo, but it's there. And if the 4th slot is used, then the triple channeling will be disabled, which can slow down the performance. So if a matching pair of DIMMs is installed in the first two slots and another matching pair of DIMMs is installed in the third and fourth slots, then the memory controller will use dual channels. Now dual channels are not as fast as triple, but certainly better than single channels. Now the latest memory technology is quad channeling. It was introduced with the Intel Sandy Bridge chipsets and the processors. Now as the figure shows behind me, we have a motherboard with the LGA 2011 socket and 8 memory slots. The processor can access 4 slots at the same time. Now the 4 black slots can be addressed by the processor on the memory channel and the 4 blue slots on another channel. Now recall from an earlier chapter that the second generation Sandy Bridge processor contains the memory controller within the processor package, rather than on the chipset. Now to get the highest performance, memory slots are placed on either side of the processor in order to shorten the length of the memory bus. Now because of the high performance of processors that use the LGA 2011 socket, Intel recommends that systems using this socket use liquid cooling methods. Now let's talk about DIMM speeds. Now DIMM speeds are measured either in megahertz, such as a 1333 megahertz or 800 megahertz, or a PC rating such as PC 6400. Now a PC rating is a measure of the total bandwidth of data moving between the module and the CPU. Now to understand PC ratings, let's take a look at an example of a DDR DIMM module that runs at 800 megahertz. Now the module has a 64-bit or 8-byte data path. Therefore, the transfer rate is 8 bytes multiplied by 800 megahertz, which yields 6400 meg per second. Now this value equates to the PC rating of PC 6400 for a DDR DIMM. A DDR2 PC rating is usually labeled PC2, and a DDR3 would be labeled PC3. Now, as the figure shows behind me, the memory ad shows both the megahertz and PC rating. Now, some current PC ratings for DDR3 are PC3 16000 or 2000 megahertz. Now, PC3 14400 or 1800 megahertz, the PC3 12800 or 1600 megahertz, and the PC3 10600 or 10600, which is 1333 megahertz. Now, a couple of current PC ratings for DDR2 memory are PC2 6400, PC2 5400, and the DDR memory might be rated as PC 6400 or PC 4000, PC 3200 or PC 2700. An older 168-pin SD-RAM DIMM might run at PC 100 or PC 133. Single-sided and double-sided DIMMs. A DIMM can have memory chips installed on one side of the module, called a single-sided, or both sides of the module, called a double-sided DIMM. Most desktop and laptop processors address memories that at 64 bits at a time. And the memory bank is the memory a processor addresses at one time and is 64 bits wide. And a DIMM slot provides a 64-bit data path. So, however, some double-sided DIMMs provide more than one bank, which means the chips on the DIMM are grouped so that the memory controller addresses one group and then addresses another. Now these DIMMs are said to be dual ranked and don't perform as well as DIMMs where all the memory is addressed at one time. Now notice in the memory ad also that the second item listed shows dual ranked as a feature. So those are some of the things that you want to be able to look for when you're checking out memory ads and you're looking to purchase memory. Now let's talk about error checking and parity. Now because DIMMs are intended to be used in servers, they must be extremely reliable. So we have to have something called an error checking technology. And the error checking technology is called ECC, or error correcting code. And some of these SD-RAM, DDR, DDR2, and DDR3 memory modules support ECC. Now a DIMM normally has an uneven number of chips on the module, but a DIMM that supports ECC would have an odd number of chips on the module. Now the odd extra chip is the ECC chip. Now ECC compares bits when it's written to the module to what is later read from the module. And it can detect and correct an error in a single bit of the byte. Now if there are errors in 2 bits of a byte, the ECC can detect the error but cannot correct it. The data path width for DIMMs is normally 64 bits, but with ECC, the data path width is 72 bits. Now the extra 8 bits are used for the error checking. Now ECC memory costs more than non-ECC memory, but it is more reliable. Now for ECC to work with the motherboard and all the installed modules, then must also support it. Also, it's important to know that you cannot install a mix of ECC and non-ECC memory on the motherboard because such a mixture causes the system, well, not to work. So as with most other memory technologies discussed in this lesson, when buying memory to add to a motherboard, match the type of memory to the type that the board supports. And to see if your motherboard supports ECC memory, look for the ability to enable or disable the feature in the BIOS setup, or check the motherboard's documentation. Now as the figure shows behind me, the one ad for DIMMs, the first 3 items are non-ECC, and the last item is ECC memory. You'll also notice that the first 2 items offer DIMMs in a kit of 4 DIMMs or 2 DIMMs. Now refer back to the memory ad that we had earlier, and you'll see an item that is non-ECC memory and has an x64 in the ad. The second item is ECC memory and has an x72 in the ad. The 64 or 72 is the width of the data path for non-ECC or ECC memory. Older SIMs used an error checking technology called parity. Now using parity checking, a 9th bit is stored with every 8 bits in a byte. Now if memory use is using odd parity, it makes a 9th or parity bit either a 1 or a 0. Now to make the number of 1s in the 9 bits odd, it makes the 9th bit or parity bit either 1 or a 0, and to make the number of 1s in the 9 bits odd. Okay, we have to add the 8. Okay. Now, you get that? I did. So, that'll tell us whether or not we're using parity if we have the odd bit. And then if a parity error occurs, a parity error always causes the system to then halt. On a screen you would see the error message parity error 1 or parity error 2 or a similar error message about parity. Parity error 1 is a parity error on the motherboard. Parity error 2 is a parity error on the expansion board. Now as you can see behind me in the graphic, it shows a SIM for sale. Now it's pricey because the old technology is hardly ever used, so therefore there's less of them out there. Notice that the module is non-parity memory. Now in the ad, the SIM is called EDO memory, or extended data out. Now it is a technology used by SIMs. Now buffered and registered DIMMs. Buffers and registers hold data and amplify a signal just before the data is written to the module. Now using buffers is an older technology that is older than, say, using registers. Now some DIMMs use buffers, some use registers, and some use neither. Now if a DIMM doesn't support registers or buffers, it's referred to as unbuffered DIMM. Now if we take a look at the ad here, you can see a kit of DDR3 unbuffered DIMMs and kits of registered DIMMs. Now notches on the SD-RAM DIMMs are positioned to identify the technologies that the module supports. And as you can see, the position of the notch on the left identifies the modules as registered or RFU, buffered or unbuffered memory. The notch on the right identifies the voltage used by the module. Now the position of each notch not only helps identify the type of memory, but also prevents the wrong kind of module from being used on the board. Now we want to talk about CAS latency and RAS latency. Now, two other memory features are CAS latency, which stands for column access strobe, and RAS latency, which stands for row access strobe, which are two ways of measuring access timing. Now, both features refer to the number of clock cycles it takes to write or read a column or row of data of memory module. Now, CAS latency is used more than RAS. Lower values are better than higher ones. So, for example, a CL8 is a little faster than a CL9. Now, as for memory modules, sometimes give you CAS latency value within a series of timing numbers, such as 555 or 15. And the first value is the CAS latency, which means the module is CL5. The second value is RAS latency. The second value would be our RAS latency. Now, if we look back at the figure, we can see that two DDR DIMM kits are rated at CL9 and one is rated at CL7. Just to give you an idea of how we're setting things up here. Now, the RIM technologies direct Rambus DRAM, sometimes called RDRAM or direct RDRAM, or simply Rambus or Rambus RAM, which is named after the Rambus Incorporated. Now, the company that developed it, Rambus, made a Rambus memory module, and it is called a RIM. Now, RIMs are expensive and are now slower than our current DIMMs. Now, no new motherboards are built today to use RIMs, but you might be called on to support some old motherboards that still use them. Now, RIMs that use a 16-bit data bus have 2 notches and 184 pins. RIMs that use a 32-bit data bus have a single notch and are 232 pins. The 232-pin RIMs can support dual channels. Now, RIMs can be ECC or non-EC, and they vary in size and speed. And size can vary from 64 meg to 512, and speed ratings are 800 megahertz or 1066 megahertz. Now, with RIMs, each memory slot on the motherboard must be filled to maintain what we call continuity throughout all the slots. So if a slot does not hold a RIM, then it has to hold something called a placeholder module, called a CRIM or a continuity RIM, to ensure continuity through all the slots. The CRIM contains no memory chips, and the CRIM is shown here behind me. Now, if we look at the memory technologies and their performance, so we're going to summarize the different memory technologies, and let's consider how they affect overall memory performance. Now, factors to consider when looking at the overall performance of memory are listed next. Now, the total RAM installed, the more memory there is, the faster the system. They generally use as much memory in the system as the motherboard and the OS can support and that you can afford. Now, the memory technology used, DDR3 is faster than DDR2. DDR2 is faster than DDR, and DDR is faster than SDRAM. Now, when required by the motherboard, buffered or unregistered memory can improve performance. Now, for all these technologies, use what the board supports. The speed of memory in megahertz or PC rating. Use the fastest memory the motherboard supports. If you install modules on different speeds in the same system, the system will run at the slowest speed or might become unstable. Know that most computer ads give speeds in megahertz or PC rating, but some ads give both. ECC or non-ECC. Non-ECC is faster and less expensive, but might not be as reliable. Use what the board supports. CL or RL ratings. The lower, the better. Use what the board supports. Although most boards don't specify a particular CL rating, the CL rating might be expressed as a series of timing numbers. Single, dual, triple, or quad channeling. DIMMs at different capacity or speed can function on the motherboard in single channels as long as you use DIMMs that the board supports and then match the ECC ratings. However, to improve performance, use dual, triple, or quad channeling. If the board supports the feature, use it. To use dual, triple, or quad channeling in manufacturing in each group of channel slots. These matching modules are sometimes sold as memory, or memory kits, Now, when selecting memory, you need to know one more fact about memory technologies. On the motherboard, the connectors inside the memory slots are made of tin or gold, as are the edge connectors on the memory modules. It used to be that all memory sockets were made of tin, but most are made now of gold. You should match tin leads to tin connectors and gold leads to gold connectors to prevent a chemical reaction between the two metals, which can cause corrosion. Corrosion can create intermittent memory errors and even make the PC unable to boot. Well, that's all we have for you for now. Come on back later, do any labs that we may have on the system for you, and when we come back, we're going to discuss how to upgrade the memory and then answer the simple question, how much memory do we need? That's all for now, and I'll see you later. Bye.